Hello, everybody. Welcome to a new episode of the Dissenter. I'm your host, Ricardo Lopes, and today I'm joined by Dr. Curtis Marean. He is Foundation Professor and Associate Director at the Institute of Human Origins at Arizona State University in the US. Dr. Marean's research interests focus on the origins of modern humans, the prehistory of Africa, the study of animal bones from archaeological sites and climates and environments of the past. In the area of the origins of modern humans, he is particularly interested in questions about foraging strategies and the evolution of modern human behavior. He has a special interest in human occupation of grassland and coastal ecosystems. So, Dr. Marean, thank you a lot for taking the time to come on the show. It's a pleasure to have you on.
It's a pleasure to be here. Thank you for inviting me.
Okay, great. So, I've already had some archaeologists on the show, but it's interesting that, I guess, if I'm not mistaken, of course, that you do work on a specific branch of archaeology that is called zooarchaeology, right? Could you tell us what it is about?
Right. So normally archaeologists will specialize on a particular method, a method being the type of procedures they use to investigate the past. And in the laboratory, the primary method I use is called zooarchaeology, and that is the study of animal bones from archaeological sites. So my focus is examining the fossil bones that come out of the sites, and in Africa those are normally from antelope, wildebeest, hartebeest, buffalo, that sort of thing. But also in a coastal ecosystem you can get people exploiting seals, so you can have seal bone. And we study the bones for indicators of butchery, how people butchered the animals, whether they removed meat, whether they transported them in certain ways, and also whether they did cooking behavior or didn't do cooking behavior, whether they removed meat for drying it or for immediate consumption, that sort of thing. So in the laboratory, I do zooarchaeology. The other major method that I employ is field archaeology. So we would also consider field archaeology a method, and not everybody is a field archaeologist. Some people just work in the lab, which is fine. But I also direct excavations in South Africa.
Yes, that's very interesting. And is zooarchaeology in any way connected with the study of past environments and climates? That is another topic you're interested in.
Yeah, and in fact, some of the first work I did with zooarchaeology was for reconstructing environments. And the way that you do that is animals have particular types of habitats that they live in. So grassland habitats, woodland habitats, and they normally specialize. So we can use the animal and its presence in the past to reconstruct what the environment was like over time. And if you study a long sequence, 100,000 years of a sequence from an archaeological site, and you have bones all the way up, you can use that sequence of changing animals to reconstruct the changing environment.
Yes, so one thing that we can do here with all of this information coming from archaeology in general and zooarchaeology in particular is that we can establish connections between diets, nutrition, and climate and past environments, right? Because we can also know what kinds of foods certain animals like humans might have available to them back when they were evolving in a particular period of time due to climate data. Right.
Exactly. Yeah, and what's important to us is the kinds of animals that people hunt. That has a big impact on the type of technology that they have and the way that they organize themselves. So for example, in South Africa, 18,000 years ago, most of the coastal sites are dominated by animals that you would normally find in a grassland migration ecosystem. So if you can visualize Africa, wildebeest, zebra, so on, buffalo. But then around 12,000 years ago, those all disappear, and they're replaced by very small antelope that you normally find in bushy habitats. And that's because 18,000 years ago was a glacial phase, and there was a big area exposed in front of the caves that are currently coastal. So they weren't coastal 18,000 years ago. And there was a migration ecosystem sitting in front of them. So the animal bones become very informative on what the past habitats were like. And of course, the social organization of people hunting open habitat grassland animals is going to differ from that of people hunting small antelope that live in the bush.
Mm-hmm. Yes, that's very interesting because I guess that is not one type of connection that people would easily make between the type of diet that we had and the kind of sociality that we evolved. Correct.
Right, yeah. So, if you're hunting very large, grassland animals tend to be very large-bodied, and they tend to move a lot. So if you're hunting migratory animals, you probably don't follow them. I mean, we have figured out that for the most part, hunter-gatherers don't follow the migrations of animals, but rather what they do is they wait for the migration, then they intercept them, and then they try to kill a lot so that they store the meat through the seasons, right? So that's a very different strategy than hunting small buck that may live in the bushland habitats that are around all year round. So yeah, it has huge implications for people's behavior.
Mm-hmm. So, I mean, one of the major things when studying human foraging from an evolutionary perspective and try to understanding perhaps what were the best strategies to use in a particular environment, in a particular set, is really knowing the types of foods that were available. Right.
Exactly. Yeah. So normally, for example, if you're going to do intercept hunting of migration animals, you have to bring a lot of people together to do it. It's often done by 20, 30, sometimes 100 individuals. And so there you have challenges in terms of the organization of the people. And that's very different, again, from hunting small animals where you would probably hunt them with one or two people.
Mm-hmm. Mm-hmm. And another very important aspect here, I guess, apart from this, from our sociality, is that when we change diets, for example, by moving from, I'm not sure what we were before we start eating meat, but I guess that we ate, I mean, like fruits and things like that, or what was it?
That's a great question because the earliest evidence we have for meat, regular meat eating in human evolution is about 3.4 million years ago.
Yeah.
Okay, and the last shared common ancestor with chimps goes all the way back to 7 or 8 million years ago. So what was that hominin eating at that time? We don't really know, but what the evidence that we have, which comes from isotopes from the teeth, would suggest that they were eating primarily nuts and seeds and bushy vegetation that's in bushy habitats, fruits, like you were saying. And then there's a shift to grassland foods, which would include animals that live in grasslands.
Also, because at a certain point we moved from the rainforest to the savanna, correct?
Yeah, that's the general feeling. I mean, humans are eclectic in habitat choice, right? So humans can live pretty much in every habitat, but it's probably reasonable that 5-6 million years ago, the ancestor of the hominin line was probably living in a more restricted range of habitats, probably woodland, bushland, something like that. Yeah.
Yeah. So, since you referred to our last common ancestor, you were talking about it as an hominin, right? Because there's this
Right,
distinction between hominin and hominid, right?
right, right.
Hominids include chimpanzees, bonobos, I guess that also gorillas, right?
Yep,
So,
yep.
but this last common ancestor, if we were to find it, it would already be a hominin.
It would be the last common ancestor would be a hominid,
All right.
and then we would recognize hominin by the evolution of bipedality. That's the key. That's the key trait. Okay, so as they begin to diverge, uh, at the origin point of that divergence, it's probably has something to do with locomotion, and that would be the movement toward upright walking, bipedality. Yeah.
Oh, okay. So that's the main criterion to distinguish hominids from hominids.
Right, right. A lot of people would, if you were talking to specialists about that particular issue, they would debate some of the specifics because there's other rearrangements of the skeleton that have to take place. But that's the key. That's the key trait.
Yeah.
Right.
I also wanted to ask you about that because in Portuguese, at least, I don't think we have two different words for hominid and hominin. I think we use hominid for all of them or something
Yeah,
like that.
I think. Well, yeah. I mean, the Portuguese colleagues I have work on mostly later periods.
Yeah.
So they work on origins of modern humans and Upper Paleolithic and stuff. So I don't know, but I'm sure if a Portuguese scientist was writing a technical paper about it, they would use both.
Yeah, sure, for sure. So, I mean, and since we're talking about food and diet, how important in our evolution was the introduction of stone tools?
Stone, yeah. Well, it's hard to say. Okay, so what my colleagues and I have been working on this for a long time, and in 2010 we published a paper in Nature on stone tool modification to fossil bone that was 3.4 million years old, and this created a great deal of debate, right? And it's still being debated. But what was interesting about that paper and what created the debate was the earliest stone tools that we had were 2.5 to 2.6 million years old. And we were arguing that there were stone-inflicted butchery marks on bones that were 3.4 million years old, so significantly before. And what we argued was there was a stage of technology of the use of stone tools where hominids were probably using naturally broken stone as opposed to flake stone. Okay, and so what I would argue is that there's also almost certainly a stage of technology that predates the use of naturally broken stone. Okay, and that probably is organic technology. So things like sticks, broken bones. So the shaft fragment from a mammal long bone is really sharp. It's like a stone tool. And my guess is that was probably the first encounter with sharp edges that hominins had. And they probably used those, and that was a stepping stone to stone technology. Okay? So I think the earliest stone tools, I don't think were probably revolutionary. I don't think they were, game-changing technology. And they're actually quite rare, right? So we now have stone tools that are 3.4 million years old, but they're very rare. So I think that stone tool technology, it probably was used intermittently. It probably could have been invented and lost several times. And it doesn't really kick in to be really common until maybe 2 million to 1.8 million. And then around then is when I would say stone tool technology has a big impact on hominid adaptation. Okay, so we have a phase, a long phase, when it's it's being used sometimes not revolutionary, but then all of a sudden around 2 million to 1.8 it really explodes. Okay.
So that time frame we're talking about around when Homo erectus was around, right?
Right. So, 2 million to 1.8 is kind of the transition time from early Homo. What, taxa that would fall into that group would be Homo habilis. And then you have Homo erectus at 1.6. So there's a big change in the hominin lineage at that time. And that's probably associated with this new commitment to stone tools as your primary adaptation. But it took a long time to get there, right?
Yeah.
Hominids, if you think about it, so if hominids are experimenting with stone tool technology at 3.4 million years ago, wow, it took a long time before it really kicked in and had a big impact at 2 million, okay?
Yeah. And here, when you're talking about this impact, is it associated with cumulative culture also or not? I mean,
Yeah.
is it the case that it's associated with an evolution of the way stone tools were manufactured or not?
Right, right. In my opinion, cumulative culture doesn't really become significant until much later.
Okay.
Okay,
Around when exactly then?
300,000 years ago, something like that.
So more or less when Homo sapiens appeared.
Yeah,
Yeah.
yeah. And the reason I think that is because, I would make a distinction between technology and culture.
Okay.
Okay, and I think this has gotten a little muddied by the primatology folk who are now saying chimps have culture and so on. That's not culture as originally defined in anthropology. No way. Because in anthropology, culture was always transmitted through a symbolic medium. And that symbolic medium is language, teaching, symbols, and so on. What chimps, in my opinion, what chimps have and other termites have it and so on, is they have technology. But it's not transmitted in a symbolic manner, which means to me it's not culture. And I don't think you really get the impact of cumulative culture until you have this system for transmitting the knowledge through a symbolic means. Okay? Now, I probably differ significantly from many of the cultural evolutionists on that topic. But I think they've made way too much of what we see in the archaeological record prior to 300,000, 400,000 years ago. If cumulative culture to me was, I think, if cumulative culture was really significant, you wouldn't have had the Acheulean last 1 million years pretty much exactly the way it was at the beginning. That's just a technological solution, and it's not changing at all. So, yeah. And then once cumulative culture kicks in, 300, 400,000 years ago, then we really see an explosion of complex technologies.
Yes, wasn't there also what people sometimes call a cognitive revolution around 50,000 to 75,000 years ago, when things like religious, religious acts and religious rituals and things related to the arts started appearing more and more? Wasn't there also that sort of explosion around that time?
Well, the idea of an explosion around 40,000 that idea has been around for a long time. And I think, we've pretty much falsified that idea in Africa. So we have evidence, people are are working ochre, and that ochre is being used to make pigments and so on by 160,000 years ago. And we have evidence for that at the field site that I direct at Pinnacle Point in South Africa. So people have the capacity for symbolic thought in Africa at least by 160,000 years ago. Mm-hmm. And I think probably, that probably we will push that back over time. Yeah. I'm a little skeptical of some of the earlier evidence that we have so far. At 160,000 at Pinnacle Point, we have beautiful pieces of ochre. They are ground. You can see people rub them against stones and so on. And some of the stuff from East Africa that's 300,000, it's a little, it's not like that. It's a reach to me to really see that as ochre that was used to produce pigment. But that's scientists arguing over the details. So I think by the time that you have the modern human lineage, the lineage that leads to all of us on the planet today, which is sometime between 200,000 and 150,000 years ago, a modern cognition is in place by that time. Okay? What I think the big difference is that then later you see an evolution of the proclivity to cooperate at really high levels that modern humans also have. And I think it's that the evolution of that other trait, cooperation, which is really the game changer for human evolution. And then that allows modern humans, which were restricted to Africa, to leave Africa and very, very quickly, conquer the planet.
Mm-hmm. Yes, so let me just ask you this, because whenever I talk with anthropologists, for example, and we refer to modern humans, sometimes we have to clarify what we're talking about, because sometimes people mean anatomically modern humans, right? But they they exclude the cognitive or the psychological side of things, and they say that it came much later. But are you saying, for example, that when we were anatomically modern, just a little bit after that, probably we were already cognitively modern as well?
Yeah, so the thing to remember is that anatomically, and even at the level of a population, we can refer to Homo sapiens, but it doesn't mean that if we sampled people from that Homo sapiens population, they would be like us. Okay? Sure. So modern human is kind of a general term, perhaps a little imprecise, that refers to the people who are alive on the planet today. And those people have an anatomy and morphology which is similar and falls within the range of variation of the earliest anatomically Homo sapiens fossils. Mm-hmm. But they have a psychological machinery that could be very different. Right? So, and the other thing is that, if we imagine the world at, let's say, 250,000 years ago, so in Africa, almost certainly Homo sapiens was present, yes. Right? And Africa's a big continent, really, really big. So there would have been variation among those Homo sapiens populations around Africa. And in my opinion, only one subset of that Pan-African Homo sapiens gives rise to all of us. Mm-hmm. Okay? And then it's at that point, that subpopulation is modern humans. Mm-hmm. It has all of the anatomical and psychological machinery that we have. Mm-hmm. Okay? Yeah. Okay? And then that one is the only one that survives on the planet today.
Mm-hmm. Yeah. Okay, so we will come back to that point of the subpopulation later in the interview. But let me ask you now, we've already talked about stone tools. What about fire? how important was controlling fire in our evolution? Because last year I had on the show Dr. Richard Wrangham, and we talked a little bit about the cooking hypothesis. And I mean, it seems to me at least that it has a wealth of evidence behind it. I mean, the fact that when we started cooking, it was easier for us to break down macronutrients, and then our guts started decreasing in size, and also it was easier for us to have more nutrients and energy available to grow our brains. So just to put it in a simple way, let's say. But were there any other applications that fire had, or not?
Right. So yeah. So Richard Wrangham has focused on the nutrient benefits in cooking with fire, and there's no doubt about that. I mean, I think he's made a very persuasive case that cooking various types of food improves the quality of your access to the nutrients and so on. When fire occurs and whether or not fire and the use of fire to improve the nutrient return of foods was a breakthrough thing to human evolution, it's still up for debate. And though he's made a good case, he's provided a great hypothesis, we now need to get down to work and test it. And that is going to involve quite a bit of work trying to figure out on the timeline when controlled use of fire and so on became important. Now, fire has other things that it does for humans. And, the simplest things would be like producing light, producing heat, helping keep predators away. But something that Polly Wiesner has written about, and she's a faculty member here at ASU, one of the world's great field ethnographers. She did her work with the Bushmen, the Khoisan people.
Okay, so by the end you will have to give me her name again.
Yeah, she's great. She's argued, she wrote a beautiful paper about how fire extends the day and allows really complex social information to be exchanged between people. Because they sit around the fire at night and talk and plan and tell stories. And she's made a really good case that this is kind of in terms of the sociality of humans, this is a big breakthrough. Okay?
Yeah.
So there's that part. The other part is that eventually what people do is they use heat and fire to transform their technology. Okay, so our technology is, we bang heat metal and bang it and produce cars, and without that, we don't have our modern technology. And that comes from ceramics, right? Learning how to use a furnace to heat clay and make vessels and so on. But that has an earlier stage, and the earlier stage of that is using heat to transform stone to make it higher quality to flake stone artifacts. And so that's the origins of what we might think of as pyrotechnology, right?
Yeah.
Pyrotechnology isn't just having a fire, it's using heat and fire to make things. And the earliest evidence for that pyrotechnology is also the coast of South Africa. And it's also about 160,000 years ago. And that was a paper that we published in Science in 2009. And that's still our earliest evidence for heat treatment. In heat treatment being heating raw materials to make them better for flaking stone artifacts.
Okay, so talking specifically about human foraging, there are several different optimal foraging models, right? So, is it the case that there's one that is better than all the others that would apply optimally to all environments, or do we have to tackle this question on a sort of case-by-case basis and look at the ecological conditions, the foods that are available, and so on and so forth.
Right, right. Well, look, I mean, optimal foraging theory and optimal foraging models that you're talking about are really just basic economic models. And that economic model is based on the idea that a rational organism will try to maximize returns and minimize costs, right? So, when you go to the grocery store, you look around and go, oh, wow, that's on sale today. I'm going to buy that one as opposed to that one. And you're maximizing your return and minimizing your cost. So optimal foraging models, that's all they do. And they are formal, and by formal I mean mathematical representations of the decision-making process. So there's a body of theory, mostly of which was developed in ecology, animal ecology, that we call optimality theory, optimality foraging models. And in human origin studies, anthropology, we've borrowed those to help us understand the decisions that hominids could have made and early modern humans might have made and so on. We know that, look, humans are weird, right? We have other preferences, okay? Right. So for example, it might pay, if we did a formal optimality model, it might pay for a male to go out and collect mice all the time in terms of the return of meat relative to his effort. But on the other hand, he may find that if he plays a riskier game and brings back a big antelope, he gets greater access to women. Right? While the guy just collecting the mice doesn't do that. And that's because women have other preferences that they may use hunting behavior to measure, such as a man's strength and courage.
Yeah.
Okay? So it's a very complex world, and so we use models. Models are simplifications of reality, right?
Yes.
And there's a famous statement, about that. And what we try to get at with a model is getting a good fit that helps us explain components of behavior. And in that case, optimality models are useful, okay?
Okay, so could we say then that they are scientifically useful, but they are not 100% accurate when comparing with the de facto behavior?
Right. So if you think about it this way, and the famous statement is, all models are wrong, some are useful.
Yeah.
Okay? A model is a simplification of reality, so it has to be wrong to a certain extent. But if it's useful, then you employ it to try to understand the system better.
Sure.
So we're always so people who work a lot with optimality models, I work a lot with optimality models, we're always trying to make them more useful. And one thing we've done in our project is, so optimality models, since they're derived from economics, are analytical. So normally what that means is it's a mathematical equation with a closed solution, right? But what we've started to do is we've started to build optimality models into computer simulations using agent-based modeling. And there we find it really helpful because it's never an either or in a simulation. Simulations create their own interesting, unanticipated results, okay? Yeah. So I think that optimality models are going to become more and more powerful as they're joined with simulation, social modeling.
Yeah, and this then allows for you to make some predictions that then you can test in the field, right?
Exactly. Yes.
Okay, so another question now. We've already touched a little bit on this, on culture and cumulative culture, but there's the question about what were the selective pressures that really led us to develop the necessary cognitive tools to be able to have culture, right? So, and one of the theories coming from Robert Boyd and Peter Richardson that I've already had on the show, they say that the main selective pressures were the fact that during the Pleistocene we had a lot of environmental fluctuations, and so to keep up with that we eventually evolved the necessary cognitive apparatus to develop culture and cultural tools and things like that. So I mean, do you agree with that or not?
Yeah, I'm familiar with it, and Rob Boyd is a colleague of mine here at ASU, so I'm well familiar with the work. It could have been important, but I don't think it's sufficient to explain what happened. And the reason it's not sufficient is only one species evolved all that cumulative culture and became modern humans, while many, many species were subject to the same Pleistocene fluctuations in climate change.
Sure.
So Neanderthals, for example, based in Western Europe, were subject to far more environmental fluctuation than modern humans in Africa.
Yeah.
Right? So why didn't Neanderthals evolve this super complex culture and conquer the world? They didn't. Yeah. It was, in fact, the definition of a tropical environment is one that has very little environmental change, right? So Africa has had a very muted record of environmental change relative to Western Europe and Asia as well. Yet it was in Africa that we see the evolution of modern humans with cumulative culture. So yeah, it's I think it was important, but it's not the key. It's not the key feature that resulted in the origins of modern humans.
So there were probably many other factors.
Well, we don't know. It's always, single factor explanations are dangerous because they tend to put a lot on one single thing, and if you've got it wrong, then the whole theory's wrong.
Yeah, it all collapses.
The whole thing comes collapsing down. So that's what worries me about Richard Wrangham's. If you read his book and you hear him give a talk, everything was due to fire. Well, what if we find out that fire wasn't really controlled by hominids until much later? Then the whole thing's gone, right?
Yeah.
What I've argued, a key step to getting modern humans, right? So a Homo sapiens that has the three key features of modern humans: this, advanced cognition, the proclivity to cooperate at really high levels, and a really special form of social learning. I think to get to the cooperation one, you have to have a shift in diet to resources that are really dense and predictable, and those stimulate warfare. So that happens in Africa, and it happens early, probably 150 to 200,000 years ago. And I think that was a key feature, but if you just followed my argument, it only explains one of the three key features. Right? So I don't think we have a general theory yet. To have a general theory, you have to have all of the characteristics of modern humans explained. And we're working on that.
No, but that's great. That's science, right?
Exactly.
Yeah. Okay, so now we probably could go back to your Homo sapiens subpopulation from which we supposedly all derive, And maybe you could tell us a little bit more about that, and how in fact we survived after the last ice age, where humans were really reduced to just a few thousand, right?
Right, right. So if you followed me, what I've been arguing is that um, the origin modern human population was probably small. It was probably from one region in Africa, uh, and we're still trying to figure out what that region was. Okay,
Okay.
was it North Africa? Was it Central Africa? Was it Southern Africa? And um, the reason it's a pretty good bet that it was one region was because when the lineage evolves that leads to all of us, Africa was in a long glacial phase, and during their glacial phases, uh, the Sahara gets really large. Okay, and that cuts off sub-Saharan Africa from the rest of Eurasia. And uh, and during those times, Africa is relatively dry, so the terrestrial habitats, their productivity is lower. Okay? So what I've argued is that coastal habitats provide the best refuge for a population during that time. So, coastal habitats, if you know how to exploit them, would be a great place to be. And the other thing is that those coastal habitats would have dense and predictable resources. So people would be fighting over them. They would be competing for them. Okay? And so I've argued that the most likely location for the origin population for modern humans would be a place where there are dense and predictable resources that would be high productivity through glacial phases. And the best place for that is the coastal areas of southern Africa. Okay? And the empirical record fits nicely with that because that's where we have the earliest evidence for really complex technologies and symbolic behavior and so on. Now, other scientists would say, hold on, wait a second, it could be coastal North Africa. It could be Central Africa, which at that time, much of Central Africa was probably a rich grassland habitat instead of a forest as it is today. So I think, over the next 10 to 20 years, we will increasingly be trying to figure out where that population came from. I think we can now exclude North Africa as the origin point for the modern human lineage because they just don't have any occupations there during the sweet spot, right? The 200,000 to 130,000. North Africa seems to be abandoned. So so we don't have a conclusive argument. I have a hypothesis. I've written about it. It's out there. It can be tested, but we don't have a conclusive result.
Okay, so now I have to ask you about this because last October there was a study that came out. The article was titled "Human Origins in a Southern African Paleo-wetland and First Migrations." It was published in Nature, and basically the researchers there placed the origin of humans in northern Botswana, in a region south of the Zambezi River, as they say. So, did you read that, and what do you think about it?
Yeah, it's a very interesting paper, and once again, the genetic work is pointing toward the Southern African subregion. Okay, so we've had multiple studies of that type, and they tend to point to the Southern African subregion. I was interested in the fact, and I think it was an interesting idea that they're arguing that the wetland resources were, again, they're pointing toward resources that would be providing a refuge during glacial phases. So they're arguing for riverine resources. I think that's a weakness, actually, in some ways, because for riverine resources to be productive, you have to have complex technologies like harpoons and nets and stuff like that.
Right.
You can exploit the intertidal zone. You know, you have a really rich intertidal zone in Portugal, and you know, you can go out and exploit shellfish and so on with really low technology. You just need to know how tidal systems work and so on. But you know, harvesting riverine and lake resources requires complex technology, and that's not present at that time, and they don't have any evidence for that. And the other thing that there's a slight problem is that populations have moved around in the southern African subregion a lot over the last 200,000 years. So using modern populations to nail such a precise place for where the origin population was 200,000 years ago, I think that's a little too much. Because the populations could have shifted all over the place, right? And Botswana has ancient populations in it because Botswana is a desert, and those hunter-gatherers have found refuge there from agriculturalists over the last several thousand years because agriculturalists don't want to go there. Do you see what I'm saying, right?
Yeah.
So I think they're probably picking up a modern pattern, but it's a cool study, and once again, what it does is it points to the broader Southern African subregion as having likely the origin population.
Okay, so I mean, in human evolution, there are still several mysteries that we have yet to answer properly, at least, or to have a definite answer to them. And one of them that I would like to ask you about is, do we know why was it that Homo sapiens was the only hominin species that spread across the entire globe?
Yeah. Well, I wouldn't say there's a scientific consensus, okay? But there is no consensus on that. What I've argued is it was the unique evolution of high levels of cooperation in our lineage that then allowed us to spread across the planet. But people will debate that.
Okay.
Right?
So,
Yeah.
So at least in your opinion, that would have worked as the major factor behind it.
Yeah. To me, that was the trigger. Once you had people with high levels of cooperation forming ethno-linguistic group structures, okay, so big people operating at 500, 600 people as a group, you know, that just was a game changer. And I don't think Neanderthals had ethno-linguistic group structure. They didn't exist in ethno-linguistic groups. They had a chimp level, single level society, and a population like that cannot compete against a population organized at a higher level, right? Yeah. But I like the way you phrase that. We're trying to solve a couple big mysteries in human evolutionary studies, and the reason behind the great human diaspora is one of those. We need, but something else. We often, now that we know how the basics of how modern humans evolved, we often say we're all Africans, right? Right. Even though you're Portuguese and I'm kind of a mix of stuff from all over the place, like most Americans, but I'm American and there's Japanese and so on. All of us are Africans, right? Yeah. But so we've answered that question, right? But to me, the next question that comes from that is, well, are we all South Africans? Or are we all East Africans? Or we were all North Africans? We'll eventually know that. Yeah. With the right science, right? So every time we answer one question, it leads to another more specific really interesting question.
Yeah, that's for sure. That's for sure. And we then keep finding new sites and new evidence to explore, right? And then we have to change the knowledge that we have. So,
Exactly.
let me just ask you this before I move on to the last question.
Okay.
About hominin migrations. It is well established, right, that Homo sapiens was really the only species that spread across the entire globe, right?
Right. Yep. Yep.
Yes, I was asking you that because I remember that Homo erectus also spread quite a lot, at least in Eurasia, and I think they also arrived at maybe close to Australia or something like that, if I'm not mistaken.
Well, they made it to Southeast Asia, okay,
Okay,
but they didn't make it to Australia.
okay.
Didn't make it to North and South America,
Mm-hmm.
and they didn't make it to the Arctic.
Okay.
Okay, so they never broke through into Arctic environments, and neither did Neanderthals. So the only hominid that made it to the circumpolar area is modern humans.
Mm-hmm. Yeah, and then maybe another big question would be why Neanderthals went extinct, right? Because we
Right.
haven't yet properly answered that, right? I mean, there are several different hypotheses out there, but there isn't yet a definite answer to that.
There's a lot of debate, right? And I've argued that it was that humans simply moved into those areas and did what humans often do, which is they annihilate their competition.
Hmm.
Um, and other people would disagree with that. So we're still arguing that over that point.
Okay. Okay, so maybe to establish a bridge with the last question, and since we're talking about migrations, can we call ourselves Homo sapiens an invasive species?
Yeah, we're the the most invasive species, right? That's what we subtitled my Scientific American paper.
Yeah.
And I was trying and I was intentionally using an analogy to ants, right? Because Argentinian ants, for example, they're in Africa and they're, invading everything and killing other ants and killing lizards and all kinds of stuff. Invasive species are really damaging, and modern humans have invaded every environment and habitat, and we've damaged it severely. And I tell you now, I often tell a story to my students in class, and I say, well, imagine you're a alien species, right? Kind of like Star Trek, and you visit Earth 100,000 years ago, and you look around, and there's pretty primitive hunter-gatherers in various areas, and you notice, oh, there are different species. There's Neanderthals here, and there's Denisovans over in Southeast Asia. There's this other species in Africa, and there were more around there, probably 5, 6, maybe 10. It seems like we find lots. But it's not all that interesting, right? They're making stone tools and so on, but not very exciting. You go away, and then you come back, 40,000 years ago, and what you find is the one from Africa has now spread into Europe and into Asia and into Australia, and all the others have gone extinct, right? Or most of them have gone extinct. And you go, okay, well that's interesting, but the species itself is still primitive, making stone tools and fire and camping. And then you go away, and then you come back now, right? And that species that had invaded all those other environments and driven extinct all of its cousins is now coming out into space.
Yeah.
Well, what would you do? I mean, if I was that species, I'd fire my phasers up and I'd burn that planet.
Yeah, that would be one hypothesis, I guess, one possibility. So, I mean, but just to explore, to expand a little bit more on the invasive species stuff, was it really us that wiped out all the megafauna in Australia and the Americas?
Well, there's, a lot of debate over that, but I think it's becoming increasingly clear that it was humans that created those extinctions. That's my opinion. Uh, there are other people who would disagree, and those debates, the megafaunal extinction debate, is one of the hottest debates, and
Yeah.
it gets to this. It's gotten politicized because people like this idea that indigenous.
That indigenous people are in harmony with
Yes.
nature, right?
That's just not. Humans are not in harmony with nature. We conquer nature and shape it to our needs.
Yeah.
And it doesn't matter what ethnic group you belong to. You do that, right? That's a human trait.
Yeah.
So I think we need to divorce it from the politics.
Yeah, I think that reminds me also. I think it was Edward Fisher that some time ago I heard him saying that there was this one time when he was talking with someone from a tribe from South America, I guess, where they did slash and burn agriculture. And I think that he was telling the guy that they were destroying the entire forest to do agriculture and so on. And the guy replied, "Yeah, but I need to eat," or something
Exactly.
like that.
Exactly. Yeah.
Yeah.
Yeah. That's the problem, right?
Yeah.
Yeah.
Yeah. Yeah. Okay, so maybe we could end on that pessimistic note.
Sorry.
Yeah. And okay, so Dr. Marean, before we go, are there any good places on the internet where people can find your work?
Yeah, you can go. So I'm at the Institute of Human Origins, so they can go to the Institute of Human Origins website and find more on the organization that I belong to. You can go to my Google Scholar page, right?
Yeah.
My Google Scholar page has all of the papers that I've published and the site who cited them, so you can follow along. I haven't put a lot of effort into a web presence, so I just can't seem to find the time to do it. But if you go to Arizona State University and the Institute of Human Origins, and you go to my Google Scholar page, you can find my material.
Well, at least now there will be this interview out there,
Yeah.
so you will have some web presence, let's say.
Okay. Okay.
Okay, so Dr. Marean, it was again a pleasure to have you on the show, and thank you so much for taking the time. It was really fun.
My pleasure. It's been really great. Thanks.
Hello everybody, thank you for watching this interview until the end. As you might have noticed, I've already been doing interviews with academics and intellectuals from a variety of fields for more than 2 years now. And I would really like to do it for 2 years more, or even more if I can, so I would really like to ask you to keep the channel sustainable, to please visit my Patreon page and to make a pledge there. Any amount, even $1, would already be a great help. You can also support me on PayPal. You can find all the links to it in the description box of the interview. Otherwise, and if you like what I'm doing, please share it, leave a like and hit the subscription button. I would also like to give a huge thank you to my patrons and supporters: Karen Litska, Anne Blanchett, Pererga Larsen, Lau Guerrero, Chantal Gelinas, Francis Ford, Hans Frederick Sunda, Brian Rivera, Sergio Gondriano, Janne Henninen, Ricardo Vladimiro, Craig Healy, Adam Castle, Vega Guidi, Olaf Alex, Jonathan Wiesel, David Diaz, Anian Kata, Jacob Klinkby, Matthew Whittingbird, Arno Wolf, Tim Hollesy, Henrik Alenius, John Connors, Paulina Barron, Philip Forrest Connolly, Drs. Jerry Mueller, Herbert Gintis, Rutger Voss, and Bo Weingart. My four producers, Isar Webbe, Rosie, Jim Frank, and Lucas Stafiniak. And finally, my executive producer, Michal Ruzieski. Thank you for all.